Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and today I have a special for you on mainstream research on the four basic operations of arithmetic. So let's begin. Now, if you do a search again on Google or some other engine, how did we realize the four basic operations of arithmetic? It will come up with many bullshit sites. The only good one is my site here, understanding the four basic operations of arithmetic. But wait, don't get discouraged. But there is another interesting site. It's so-called research done by uh, researchers who submitted this to the NCBI, National Library of Medicine, in, I think this is a uh, United States address, email, or not email address, email address. And in any case, so what this paper does is it considers the functional dissociations between the four basic arithmetic operations in the human posterior, parietal cortex, and a cytoarchitectonic mapping study. It's interesting because the academics who conducted this don't know what is division, don't know what is subtraction, what is multiplication. They have no idea of any of these, how we got these arithmetic operations. So their research is obviously based on what they think is or are the four basic operations of arithmetic, okay, which are, they've got them listed incorrectly here. Addition is first one, subtraction is second, but it's the other way around. Subtraction comes before addition, and they also get this order wrong, multiplication and division. So what's interesting about it is how they highlight the areas of activation, okay, areas of activation and deactivation in the brain. So when they looked at scans of addition, or what they think is addition, these areas here were deactivated. Okay, strangely enough, I mean, the blue areas were deactivated. Then, when they looked at subtraction, the blue areas again were deactivated, and the red areas were activated. Okay, that's kind of strange. And these are different views of the left and right parietal lobes. And why this interests me, you may ask, because I'm also interested in uh, how humans learn and how, if it were ever possible to build AI, this would be one of the things that we'd have to learn about first. Okay, so uh, then we have multiplication, and notice what happens here. We have a lot of activation, as you see it over here, and some deactivation in the blue areas. And of course, another view of the same application there of multiplication, what they think is multiplication. So as you can see, there's not much difference going on here. There seems to be some association between the two, and obviously these here too seem to be associated. Okay, but there's a problem here when you get to subtraction because these areas are activated, and in fact, what I'm about to do is I'm about to tell you how you got the arithmetic operations. Okay, so this has never been published before, except by me, of course, and it shows you how you got arithmetic without numbers. So once the people who did this research have studied my article, then they can come back and redo the research correctly because all this is garbage, basically. They tested uh, the subjects using what they thought was addition, subtraction, etc. Okay, but what they thought was completely incorrect. So whatever you see appearing on the site is, for all intents and purposes, 100% garbage. So how can they redo this? They can redo it by first studying my article, and then they can decide what areas of the brain are activated or deactivated. So if you're not already subscribed to my channel, become a subscriber to my channel here. Click like, follow me on Academia.edu, and to read this article here, by the way, which I'm showing you in dark mode, you have to create a free account on Academia.edu. Then you have to log in before you can read or download the article. It will tell you how you got arithmetic without numbers and also show you how it was transferred to algebra. Okay, it's a beautiful article. This information was never published before I published it. So it's original, it's new, relatively new. It's only been around a short while. I actually realized this knowledge when I was around 22 or 23, but only published it, I think, about a year or two ago. So it's brand new knowledge, and I actually sent this article to this email address here and told them they can publish it, provided they don't make any changes and they state my name in full. So obviously they're not going to do it because they're morons, but you can do it. And that's pretty much it. Till next time, I'm John Gabriel. This is New Calculus Channel. Goodbye.